Have you ever looked up and seen a massive airplane soaring overhead? It looks light and graceful, but here's a secret. A Boeing 747 can weigh as much as 400,000 kilograms, about 80 elephants. So how does something so heavy get off the ground and stay up there? It's not magic, it's science. For centuries, humans watched birds and wondered if we could fly too. Early inventors tried flapping wings, but the real breakthrough came from understanding invisible forces. These forces are always at play, whether you're sitting, cycling, or flying. Aeroplanes are machines designed to use these rules to their advantage, a cosmic dance of forces. The airplane must balance these forces perfectly to fly. So next time you see a plane, remember, it's a flying science experiment, a solution to one of humanity's oldest puzzles. It's about overcoming gravity, convincing the air to hold up a colossal weight. Let's pull back the curtain and reveal how this amazing trick is performed. To understand flight, you need to meet its four key forces: weight, lift, thrust, and drag. Imagine an airplane in the air, pulled and pushed in four directions at once. Weight pulls it down, lift pushes it up, thrust propels it forward, drag tries to slow it down. For a plane to climb, lift must beat weight. To speed up, thrust must beat drag. When cruising, all four forces are balanced. It's like a high-wire balancing act, but with a machine weighing hundreds of tons. Think of it as a tug of war. Weight pulls down, lift pulls up, drag pulls back, thrust pulls forward. Pilots and design constantly adjust these forces to control flight. Every part of the plane is shaped with these forces in mind. You experience these forces too, standing up, riding a bike, or running. Flight is just a dramatic example of these universal principles. Now let's look closer at each force. First up, weight, the force of gravity, pulling the plane and everything in it down. The challenge of flight starts here. How do you defeat gravity's pull on something so heavy? Enter lift, the hero. Lift is created by the special shape of the wings called aerofoils. The wing is curved on top and flatter underneath. As the plane moves, air travels faster over the top, creating lower pressure above and higher pressure below. This pressure difference pushes the wing upward. This is lift. The faster the plane moves, the more lift is generated. To get airborne, a jet needs enough lift to overcome its massive weight. That's why planes need long runways to build up speed for lift. It's physics in action. A simple curve lets us conquer gravity. The wing's shape turns air into a powerful force holding up our flying cities. That's the secret to overcoming gravity. Now let's look at thrust and drag. Thrust is the forward force from the engines. Early planes used propellers, but modern jets use powerful engines. A jet engine sucks in air, compresses it, mixes it with fuel, and ignites it, blasting hot gas out the back. Newton's law: for every action, there's an equal and opposite reaction. The backward blast pushes the plane forward. This is thrust. But as the plane moves, it faces drag, air resistance that tries to slow it down. It's like running through water. Air pushes back, creating drag. The faster you go, the stronger the drag. That's why planes are sleek and streamlined, to reduce drag. The battle between thrust and drag determines speed. To fly, engines must produce enough thrust to overcome drag. It's a constant push against an invisible force. So how do these four forces work together for takeoff? Picture a plane at the runway's end. Weight holds it down. The pilots push the throttles, engines roar, and thrust surges forward. As the plane accelerates, drag grows, but thrust overpowers it. Air rushes over the wings and lift starts to build. Speed is crucial. The faster the plane goes, the more lift is generated. At a specific speed, the pilot pulls back, raising the nose and increasing the wing's angle. Suddenly, lift beats weight. The plane breaks free from the ground. The wheels retract, reducing drag, and the plane climbs skyward. Thrust creates speed, speed creates lift, and lift conquers weight. It's not magic, it's physics in motion. That's the miracle of takeoff. Today's aeroplanes are wonders of engineering and coordination. Over 100,000 flights cross the globe daily, with thousands of planes in the air at any moment. Air traffic controllers choreograph this sky ballet, keeping everyone safe. Some jets fly over 17 hours non-stop, connecting distant cities. The longest flights cover over 15,000 kilometers, almost halfway around the world. Modern jets like the Airbus A350 are so efficient, they travel over 30 kilometers per liter of fuel per passenger, better than many cars. Cockpits are packed with advanced computers, GPS, and weather systems. These help pilots fly efficiently, avoid storms, and land safely. The plane itself is a network of sensors, constantly monitoring every system. Engineers are always innovating. Lighter materials, quieter engines, even electric and solar-powered flight. The airplane keeps evolving, always pushing boundaries. From the Wright brothers to today, flight is a story of relentless innovation. Next time you're in a window seat, remember, you're riding on a column of high-pressure air, thanks to the wing's shape. You're propelled by controlled explosions, harnessing Newton's laws. You're in a machine that's mastered the four forces of flight. The story of flight is about curiosity and refusing to accept limits. For millennia, we dreamed of joining the birds, and we made it happen. Flight reminds us that today's impossibilities can become tomorrow's achievements. The same spirit that lifted the first plane now sends probes to other planets and builds our future. Our quest for the clouds isn't over. Electric jets, hypersonic travel, and sustainable aviation are on the horizon. The sky was just the beginning. With science, curiosity, and courage, nothing is impossible.